Unit 1, Simplifying Rational Expressions. Today we're going to start by talking about a rational number versus irrational number. A rational number is a number that either terminates, which means ends, or repeats. For example, 5, 7.6, 1/2, 0.67 repeating. An irrational number is a number that does not terminate and doesn't repeat, or it goes on and on. Some examples would be a decimal that goes on with no pattern, pi, and a lot of our square roots. A rational number can be written in the form a divided by b, where a and b are integers, and b does not equal 0. When your denominator is equal to 0, that's what we call undefined. So undefined is when a fraction's denominator is equal to 0. You'll get questions that ask you for which values or values of x are the following rational expressions undefined. So we're looking for the value of x that would make our fraction equal to 0. So what you're going to do is just take your denominator, set it equal to 0, and solve. One-step equation. And we would write it as x cannot equal -7. Because if x did equal -7, if we plug it in, then our denominator is 0. That's what undefined means. Number 2, take your denominator, set it equal to 0, and solve. Now when we're solving these, some of them can be factored. This is the difference of two perfect squares.
Can I have a custodian?
Two sets of parentheses. X times x gives us x squared. 3 times 3 would give us 9. We need it to be negative, so we have 1 plus, 1 minus. So one of our answers, x cannot equal 3, -3, or x cannot equal 3. There's going to be two answers because there are two factors. Number 3, our denominator is 2x squared minus 2x. This is a greatest common factor question. Both terms have a 2. Both terms have an x. So if you'd like to, you can divide them by 2x, write that right in there. 2 divided by 2 will give you 1. X squared divided by x will give you x. So we got 2x on the outside. If we set that equal to 0 and solve, one of our solutions is 0. We also have x minus 1 is equal to 0. So we have another solution of 1. So sometimes you'll have one answer, sometimes you'll have more than one. Now we're going to look at reducing rational expressions by writing them in simplest form. When you have a question like number 1, where there's no adding and subtracting, you're just going to kind of cancel things out. So if I look at the numbers 3 and 9, each of those can be divided by 3. So if I divide 3 by 3, and I divide 9 by 3, I'll get 1, and 9 divided by 3 is 3. Next, if I look at the a's, a squared divided by a, it's like a to the first. You're going to subtract your exponents. Should leave you with an a. Next, the b's. Notice we have one b on the top and two b's on the bottom. You still want to subtract your exponents, but you want to write your answer where there are more. You might hear me say top heavy or bottom heavy. meaning there's more letters on the top or the bottom. The B's, there are more on the bottom. So when I subtract, I want to put my B on the bottom. Now, you don't have to write the 1 in the answer, so I would simplify this down to just A divided by 3B. Number 2, when you see adding or subtracting, you're going to try to factor first. If I look at the numerator, m plus 5, there's no greatest common factor, so that's going to stay m plus 5. The denominator, I have a 2 and I have a 10. Those can be divided by 2. So I'm going to take that 2 out and divide both of these by 2. So I get m plus 5. Now, you can only cancel when the complete factors are the same. You can't cross out an m, you can't cross out a 5. They're attached with a plus. When the whole factor is the same, they cross each other out. If there's nothing left on the top, m plus 5 divided by m plus 5 is really 1. So we'll need to fill in the numerator with a 1. Number 3, m squared minus m divided by m minus 1. When again you notice there's adding or subtracting, you need to try to factor. The top, both of these terms have an m. So it's a greatest common factor. I take an m out of each term. The denominator can't be factored. So once it's all factored, I see if any of the factors are exactly the same. The m minus 1's cross out. We're just left with m. Now these are going to get more difficult. Number 4, at the top, I see addition, I try to factor. First look at the 2 and the 8. 2 and 8 can be divided by 2. Each term also has an x. So I'm going to factor out or pull out or take out a 2x. The denominator is a trinomial, so that's one of the questions when we look for two numbers that multiply to negative 12 and add up to a positive 1. So we're going to use 4 and 3. That would give us a positive 12. We want a negative. One of them has to be negative. We want them to add up to a 1. So the smaller number would be negative. So we start with our x. We put in a plus 4 from here and a minus 3. So I see an x plus 4 in the numerator, x plus 4 in the denominator. Again, when I divide something that's the same, it's equal to 1, which leaves us with 2x divided by x minus 3. Now, reminder, you cannot cross off these x's. This is 2 times x, and this is x minus 3. Those are different operations. So our answer for this, when it's reduced, is 2x divided by x minus 3. Now, number 5, when you come across a question, we have factors that are subtracted, and they're in opposite order, like x minus 2 divided by 2 minus x. Think about that for a minute. If I take a number and subtract 2, for example, 10 minus 2, we get 8. If I reverse that, do I get the same thing? No, we do not. We get negative 8. It's actually always going to be the opposite. So if I'm dividing opposite numbers, 8 divided by negative 8, that's going to equal negative 1. And that's going to happen every single time. So be aware and look out for that. When you have factors that are subtraction and it's reversed, they cancel out to a negative 1. Adding does not work that way, only subtraction. This is the last one we're going to do together before you practice. Number 6. At the top, 16 minus 4x squared has a greatest common factor of 4. When you divide both terms by 4, you get 4 minus x squared. The bottom has a greatest common factor of 2. When you divide by 2, you're going to get x squared minus 4. So this is what we just talked about. The 4 minus x squared and the x squared minus 4 are reversed and they're subtracting. Those are going to cancel out to a negative 1. When I divide 4 by 2, I get 2. Multiplying that by our negative 1 simplifies down to a negative 2. Now I would like you to copy these questions down. Pause the video, try them on your own. When you're ready, play the video and check your solutions. Number 1, 18 divided by 9 is 2. You've got x squared on the top, x on the bottom. When you subtract the exponents, you get a 1. But there are more x's on the top, so you write your answer on the top. Y is opposite, there are more on the bottom, so your answer will go on the bottom. Number 2, you're going to leave the 3x plus 5. Denominator, 6 and 10, can be divided by 2. 3x plus 5's cancel out. Nothing on the top, so we're going to fill in a 1 to get 1/2. Number 3, top, you're going to factor out a 3 and an x. The bottom is a trinomial. You're looking for two numbers that multiply to negative 20, add up to negative 1. So that would be negative 5, positive 4. X plus 4 is cross out, leaves us with 3x divided by x minus 4, or sorry, x minus 5. You cannot cross out these x's. They are attached to 3 and attached to the minus 5. And last, the top, you're going to factor out a 4. Your x minus 2 and your 2 minus x are subtracted and reversed. So those would cross out to a negative 1. Multiply what's left. Your final solution is negative 4. Again, feel free to go back, review anything that you missed, and we'll see you in class tomorrow.